All right, so if you want to follow along, I wrote like a tutorial for this. And so to do that, you go to sc2 umich .github.io/documents. And that'll take you to the website where we keep all of our information. And then go to workshops. And then for winter 2025, Python packaging. So hopefully there's not too many typos in this. I just finished it a little while ago. But this is what we're going to be going through today. Question Wayne? Oh, you can find the file? Oh, no, yeah, so go sorry, no, just type in a different address and do sc2. So the URL is a little bit different. So yeah, just type in sc2 umich, then .github.io / and then documents. Let me check. Okay. Workshops. All right, so for a little bit of motivation, so Python is a little bit of a different language because it's an interpreted language, not a compiled language. So what it does is it takes a script of text and it reads it, and then based on what's in that script of text, it'll perform some operations on a program that's already compiled. And so when you're writing programs in Python, you can put everything into one file, one text file, and it can be thousands of lines long. And that's perfectly fine. There's nothing wrong with that, except for it becomes very hard to maintain and to change over time. So if you just keep writing and you get to 3,000 lines long and you realize you need to change something at the top of the file and you're kind of debugging it and working out what the problem is, you're going back and forth along those 3,000 lines at a time. And so yeah, Python in its very basic instance is just running these scripts of text files. But for larger projects, it can become unwieldy to only use it as only use one script for Python files. And so Python has a default feature that lets you import modules into files and to other scripts. So if you were starting your script and you wanted to include some text that was in another file, so you're kind of separating out your code and making it easier to work on, you can do that by just putting import. And so I want to spend some time here to make the distinction between modules and scripts. So modules are, so they're both files, right? So I said Python takes in text files. Both of them are text files, but modules are meant to be brought into a script. So they're meant to be called from another file. They're not meant to run on their own as a script. And so that's the usefulness of them, is that they let you better organize your code. You don't have a file that is 3,000 lines long. You have multiple files that are self-contained, and they can help you with your organization. And so to see the difference between a module and a script, we're going to make two files. And so for this, I'm going to, for this entire workshop, I'm going to make a directory for it, and I'm just going to call it workshop. And I'm going to, all the files I'm going to write into this workshop directory. And to do most of it, I'm going to use Visual Studio Code. All this is just a text editor. So if you want to use a different text editor, then that will work too. Any questions up to this point? Okay, so we're gonna make two text files. We're gonna make one called a.py and one called b.py. And in a.py, we're just going to declare a variable named foo, and it's going to be equal to 6. Oh, sorry. That's all we're putting in a.py. And then in b.py, we're going to import the contents of a.py. So you see, yeah, all that's happening in a.py is we're saying it won't even print anything out. It's just going to say, if you just run this as a script, it's going to write that into memory. I'm pretty sure it will. And then it'll just exit, and then the memory will be erased. Then for b.py, we're going to import a, and then we're also going to set a value to foo. And then we're going to print foo and then print a.foo. And so, and whatever file that we're running is going to be our script file, right? Because that's the one that we want something from. But how good it is as a script is going to depend on what's in it. So using your terminal, you're going to want to do pi, and then to run the script, you just type in a.py and run it that way. So yeah, running a.py, we see it does nothing. But if we run b.py, we see that we get two numbers. And so the first number is the number that we defined in this script, foo, and then the second number is the one we defined in the a.py script. And so you see here, this is where one level of organization comes from, because we have our module A, and it's creating a separate namespace of variables. It's creating a separate group of variables, because in both our a.py and b.py files, we made a variable called foo, but because we separated into two files, we can have them both in the same execution, both of them called foo. And the only difference is that the ones from the module have this a dot prefix on them. So already we've gone from like a very like basic implementation of Python, just running things in one script, and we're already using two different files to organize our code. And you'll see this is kind of a recurring theme as we're going to go on through packaging is you don't really need packaging because you could just send most of the time you can just send all your Python through one file. But the more you get into packaging, the more organized your code becomes. So before I mentioned that the script is the one that we're running, and like when you're talking about a module, you're usually talking about something being imported, and whatever is being imported usually doesn't have anything functional to do if it's ran as a script. But technically, both of these files are modules, and you can see that by if we put in a print statement into each of these files, or we print out the name, the module name. So the script for everything is just going to be called the main module, and we'll see how that plays out when we put these print statements in. So if we run a.py again, so we're running a.py as a script, and it's saying that this is the name of it, the module name is main. So this is the main module, aka it's our script. When we run b.py, we can actually run name here again. Name will be main, but if we run a.name, if we print a.name too, you'll see it just comes out as a. So the module, so it's kind of like a cycle, but yeah, the module A's name is A, so that's what you would expect. That's what we're seeing here on this line. Okay, so this is been very pedantic as far as the module script and whatnot. But I think it's important to know like how, like the terminology for these things. Okay, so now we're going to motivate our organization a little bit more by making some more complex files. So we're gonna make some objects. And usually when you're writing a library, the objects are like the core of it. And when you're using it for a scientific application, that's what you're going to import and use to do your simulation. So we're going to make a package that's all about 3D geometry. And so it's going to be a very basic package where we're going to have two classes. We're going to have a vertex class and an edge class. And so using these vertexes and edges, the idea is that we'd be able to describe whatever 3D geometry we want. So in the same folder that we've been working in, we're going to create two more files, just vertex.py and edge.py. And so these are going to become important modules. Whereas like in B, maybe we would import edge and vertex in here to use them to describe some sort of 3D geometry. So for vertex, for objects always have some data and some functionality associated with them. So for vertex, the data is going to be the position of the vertex in 3D space. And then it's going to have a distance function where it can determine the distance between it and another point that's provided as input. And then the edge class is going to be composed, it's going to be defined. Its data is going to be the two vertices that define it. And it's going to have a length, which you can get from the getLength function. And it has a function that can create a new vertex by bisecting itself. So it would be even better if it created two new edges instead of it, but so it's just going to create a vertex in the center of itself. So this is as complex as our library is going to get. Okay, so any questions at this point? Okay, so we've now defined all these modules, and they're going to be very helpful for our future files. So now let's get some use out of them, and we're going to create a script called line. So notice now this is a script because we're going to be running it, but we're going to be importing modules. So now we're going to run it and we're going to use both of these modules that we just made, the vertex and edge module. And so to get the objects that are in them, we'll need to first specify the module and then say what object we want from it using this dot notation. And so we're going to define a vertex at 0, 0, 0 and 1, 1, 1. And so this star here is just, so the vertex constructor takes 3 arguments. And so we're providing one argument, which is a list, but we're using this asterisk in the front to decompose into 3 separate things. So that's what that's doing. And the same thing for the edge here. The edge is just made from the 2 vertices. And then to make sure our bisect function is working right, we're just going to get the position of the node that's created when we run the bisect function. So we're going to create our line.py file. Did anyone have any trouble getting the documents page? And like, because copying and pasting this stuff's a lot easier than writing it out. Bobby?
Where is it?
Okay.
Is that GitHub?
Yeah, so type in your search bar, type in SC2 image. No, so yeah, you got, it's a little bit different URL.
Oh.
Yeah, type in SC2 image. No, yeah, just yeah, and then .github, and then .io, and then /documents, and then go to workshops, and scroll down to Python packaging. Yeah, there you go. Is everyone on Zoom able to see the screen? Okay. So now let's run our file and make sure that it's working correctly. So pi, and then you can see I'm in the workshop directory. So all the files that are in here, I can just call locally. And so we get the position that's halfway between 000 and 111. So this looks like it's working to me. So now we've made a sort of a library of useful functions with edge and vertex, and we are able to use it in a very organized way. So, it's very small now. So even if we did have the object definitions in here, it wouldn't be very large, but you imagine you can extend this pattern forward, and it's going to make your life a lot easier once you start developing very complex things. Yeah. Any problems running it on Mac or Linux? Everything okay? Okay, so now we've done organization in terms of scripts and modules. So now we're going to do packages. And actually, just creating a package, technically speaking, is very simple. So all we're going to do to create a package now is we're going to create another folder inside of our existing folders, and we're going to give it a name of whatever we want our package to be. So for the purposes of this, you can either call it geometry, or you can call it geometry underscore and then your unique name. Put your unique name at the end if you want to attempt to upload it to the Python package index. Because it has to be unique from everyone else's. So if we all upload the same package called geometry, there's going to be issues. But I will say, once we get to that point, you'll have to make an account on the Python packaging index, and it's a lot of work. I can show you guys how it works, but if you want to do it, it might take some time to set that up. So I'm going to name mine geometry with my name at the end of it, for my unique name at the end of it, and we're going to put our files in here. Okay, so it's VS Code is wanting to be proactive, but I'm not gonna do the changes it recommends for illustration purposes. So what a package is in terms of Python is just a collection of modules. So I talked about modules, the things you import. Packages are just collection of those. You collect them by putting them in a folder. And so a package can be a collection of modules, or it can even be a collection of packages. So we see that in some of the packages that we use, like NumPy, it has modules within it. So you can do even just like items in it. It's kind of a module itself. So you do numpy.ndArray, and you can get the array from that. But you can also do like numpy.linouge, and linouge is its own, I guess it's its own module, I would really say. And then there's various functions you can get from the linouge thing. So this would be the package, this would be the module. And then it could even be, numpy.something, package, then your module. So you can have a lot of complexities of nesting, and you do see that for some packages. So that's how package fits in the module script hierarchy. So to create our own package, it's very simple. Like I said, we just have to put it in a folder. And so they recommend putting in a init.py file in it as well. But I'm pretty sure it becomes a package even without you putting the init.py file in it. But what this init.py file serves as is it can help you initialize other things about your package, such as setting up search paths. So if you have some files in weird places, you can tell Python where to look for those files in the init.py. So we're gonna try some things before setting that up. So first, I just want to show you. So our line.py file, it has vertex and edge. It's still calling vertex and edge, but if we run it again, you're gonna see that we get an error. So it's like, I don't know what vertex is. That makes sense because we moved it. So it's now in the geometry.jpvelka. So when you say vertex, it's just gonna look in its current directory. But now once we look at, so once we put it in here, it's not in the current directory. So all we have to do now is say that, okay, it's actually a part of this package called geometry. Just like we would do with NumPy. Okay, so before, when testing this, I didn't have to put the init file in. We'll see if that's still true. So also you have to change all these names. You don't have to, but we'll see another option. Okay, now we'll try to run it again. File saved. Okay. So there is an issue. Okay, so now we're gonna put the init.py file in. So double underscore init.py. And it doesn't have to have anything in it. This is just gonna tell Python what to look for. Or tell Python that it is a package. Okay. After many name changes, we have now gotten to where our package works. So our package is called geometry. So now it looks like it's actually, so geometry, jpvelka, all that. So now it looks like it's even more like cluttered now than it was before. So you're like, why would you want to do this? So you can actually make it a little less cluttered, and I'm sure you guys all know this if you use Python. So you can make an alias for what your module is called, and by typing import yada yada as something much shorter. So you can say import as v, and then just replace everything with V. And that makes everything a lot more clean. So you have a few statements at the top, just defining your module, and then everything in the package is now more organized. So yeah, all you can think of the package as like all the core functionality of what you're trying to write. So it's not going to be the actual simulation that you're trying to run, but all the tools that you need to do the simulation. And so that's really the main purpose of creating a package instead of just leaving it all as modules. Because you can see it's a little bit more work to define everything inside of a package. You have to write different stuff. You have to alias it. So why is it important? It's really important an organizational term because you're separating out the core functionality from your use cases.
So, say, so what's the counterpart of this in MATLAB?
So MATLAB has functions, and John,
Yeah. What was the question, sir?
what's the counterpart of
Counterpart of this in MATLAB?
packages and modules? And
I mean, modules are kind of like functions.
Yeah,
yeah, modules are like functions. Yeah.
yeah, so you can do similar things in MATLAB, like you can define user functions.
Mhm.
And then you don't have to import them, you just have to have them like on the MATLAB path.
Yeah.
Yeah.
And so, and actually, there's a similar like path concept for Python too. And so, if it's not on the Python path, then your import function will never find it. But yes, I guess it's automatically.
Yeah, so MATLAB doesn't have paths because it thinks that users are all children. So you have like a temporary path where you can like import stuff for a single session. You still have to like add it to the path and it's not seeing the path.
Okay. Like a package, something similar to packages, is it like I remember you saying something about toolboxes?
Yeah, so they have like the official toolboxes, but like they're always all imported because what they do is they install them and then they update your path variable,
Okay,
like just include that location.
okay. That's the analog. Okay. Yeah, so you made your first package. So if you were the only one to ever use your package, then you could stop here. But if you wanted to share it with others, and that's the part that we really want to highlight today, we're going to need to do a few more steps. So first, I want to talk about what to do with your other scripts. So we've made this package to confine all of our modules. All of our modules are now living in our package, but we still have these other scripts like line.py that's sitting out here. So what is typically done with those when you're creating something that you want to share with others? So I would say line.py is something like an example file. So if you were going to publish this on GitHub and someone was like, how do I use this? This would be, you're saying, okay, this is what the bisect function does. This is how you'd use it. This is an example file. There are also other files that are typically included in things like NumPy and matplotlib, and those are tests. And so tests are just very useful things for development where you can write a new feature and then write a test for it to make sure that it works. And then other people can run these tests to make sure that it works too. So these are the two types of scripts that you're going to write if you are making a package. So they're useful for the package itself, and we want to make sure that they stay organized as well in our file system. And so we can write our first test. So we'll just call it test.py. And what we're going to do is we're going to test that the length of this edge is going to be its true length. So it's going to be the cube or the square root of 3. So 1 squared plus 1 squared plus 1 squared square root. That would be the length of this edge that we made in our previous example. And so we're going to test that that is the correct length to the tens of thousands of digits. And so that's what this assertion is doing here. So that's how you typically write tests, is you use assertion. There's actually a lot more fancy testing tools that you can use in Python, but this would be like a very simple test that you'd write quickly. So yeah, this is the same thing as before, where we're using we're making our vertices at 0, 0, 0, 1, 1, 1. Then I'll have to change our import statements here. And we can, so if your assertion fails, it'll be like, oh, error, you've done something wrong. So when we get past that part, we can say test passed. Now we can run our test. Oh, our test passed, great. So the length of our element, our get, what this is really testing is our get length function, making sure that that's working correctly. So that passed. So now we have two different types of scripts in our file. So we have our package, right? That's in this folder. We have our line script and our test script. So line is an example, like I said, and test is your testing thing. So you could, once again, you can put everything both in these files and they would become very long and hard to maintain. So you separate them into multiple files, but once you start to have multiple files, you just have many files in your folder that get difficult to sort out. So now you want to sort them into their own folders. So we're going to make a test folder, and we're going to make a examples folder. Okay. So we're more organized now, and so we're gonna run our test file again, make sure it still works. Okay, that's what I was expecting to see. All right, so now we get an error set saying our module still isn't found. Or our module isn't found again, even though it has the right, or it's not even finding our package now. So our package was geometry. So we're not even finding our package now. Where has it gone? And so we haven't moved our package at all, but what we've done is we've moved our files. And what's happened now is that our package is no longer in the default search path that Python looks for. So the search path that it looks in is the directory location where the file being ran is. So it's going to look inside this test folder for a geometry package. And so that's our problem here now, is that by organizing this, we've made Python confused and it doesn't know where to find this package. So there are ways around this that you can kind of, you can just modify the path directly and that'll fix the issue. But if we want to, there's actually like a more sophisticated way of handling this, or like a more recommended way of handling this for like full project development. But if you want to, you can just change the path that you're looking at. So we're going to say, we're going to append our current directory, which is this directory, the main directory, onto our path for our test. So if we do this, we'll see that our test works once again. make sure you do this before the inputs. All right, so our test passed. So the way, okay, so we moved our files and then when we ran it, the package wasn't where Python expected to be. So to fix this in this scenario, we changed where Python looks, but we can also move our package to where Python is looking. So yeah, so that's what building your package and installing your package is going to do. You're going to install your package with all the rest of your Python packages so that Python can find it. So that brings us to step 4, building your package. And building usually has this concept of like when you're having a C program or something, you're going to build it so that you can run it. And it seems strange to talk about building in Python because it's not a compiled language, but it actually does use components of different compiled languages to support itself. For example, NumPy uses the basic linear algebra subroutines to make its computations faster. So in a sense, Python actually does need to build some things, especially if it has parts from a compiled language. So to make this easier, Python invented a wheel file. And the wheel file is everything pre-compiled for a specific computer architecture and operating system. So if you ever install something, you'll probably see a wheel file pop up. So this is a screenshot from, or not a screenshot, but like copy paste from installing NumPy. So when you install NumPy, it'll say, with using pip, it'll say collecting NumPy and then using, so I already had NumPy installed, so I was using a different one. But you can see it's, what this is saying is using Windows, the Windows wheel for the AMD 64 architecture, and then .whl, which is a wheel file. So this is going to contain all the compiled components that you need to, all the compiled components and all the Python scripts to run NumPy. Any questions at this point? So that's what we're gonna do. We're gonna make our wheel file. So like I said, wheel files were important because it allowed you to have all the compiled parts in there, already pre-compiled. But we don't have any compiled parts in ours. There is actually ways that you can do this whole process without the wheel file, and it's using something called a standard distribution, which is basically just a compressed archive of all of your Python scripts. But we are going to we're going to do both because by default, most of the building operations will give you both, and Python, the pip module prefers wheel files. So all that we have to do to make our package buildable is we have to make a basically just like a configuration file. So a pyproject.toml, which stands for Tom's Obvious Minimal Language. If you're using a different build system, you might need a setup.py file, but for the one that we're doing, we're just going to need the pyproject.toml. So the way that these files are organized is they're broken up into tables. And we're gonna need a few tables this is what a table looks like. So this is our project table. It'll have their various key value pairs in it. And we're going to need a build system table and a project system table in ours. So the build system basically is going to specify which program you're using to build your wheel file. And then the project is going to be metadata. So who's the authors, what's your package name, what versions to support, and what dependencies are needed. And so this is a template for all of that. We're going to make our POML. And so if we don't have any dependencies, but you'll notice that like I was doing some square roots and stuff. So if you want to use like NumPy for those square roots instead of what I was doing, you would put that dependency right here. And you could even specify like the versions of NumPy that you'd want. So it's like NumPy greater than equal to 2.1. So that's pretty much all you need to do to make a wheel file. We've you also notice that we specified this hatchling build system. So this is one of the ones you can use, but the hatchling one is the one that was suggested on a tutorial. So that's the one we're gonna use. So now all you need to do is do pip. We need to make sure we have this build package installed. So this build package downloads the build backend, which is hatchling in our case, and it builds the wheel using hatchling. So build will take care of all of that. So now all we do is, so it's a module, so you run it as with -m, you do build. Okay, yeah, so some of this stuff you all want to fill in. I forgot to do that. So the name of our package, make sure this is important. Make sure your name, the name of your project is the same as the name of this folder here. And then for your author, for your name. Python version, push whatever Python version you use. So for me, it's 3.12. These you can leave alone, and these is. So yeah, so you see it's installing hatchling. So build installs hatchling and then uses hatchling to make the wheel file. So it's getting the build dependencies for standard dist. So standard dist is the compressed archive of all of your Python files, all your module files, I think. Yeah, so it made this archive file and then also made a wheel file. So you've made your package that's ready to distribute now. And these are actually things that you can install as well. So to install a package, you might want to do this in a virtual environment, or if not, you can do it in your global environment. But first, what you're going to want to do is say pip or Python, and then pip list. So you can do this to see what all Python packages you have installed at the moment. And then this is going to be a reference to see that we're actually installing our new module. Make sure you have make sure you have wheel installed. That's what's and then you're going to want to. Oh, and so it said the terminal said that we got that those files were built, and you can actually see it made a folder up here called dist, the distribution, and that's where those files are. So to install it, you just do pip install and then the location of those files. So you do dist, and then geometry wheel. So by doing this, it's going to install all of your modules in this location. All right, so just like, so sort of like how you would install NumPy, we've just installed our own package. So now, if we look at pip.list again, or pip list again, we see that we have our geometry package in there. And it's the very earliest version, 0.0.1. So before we had problems running our test file, but now we can run it. Hopefully we can run it, no problem. Our test passed. All right, so everything's working. All of our modules are being imported correctly. Any questions at this point? So when we did pip install and then this, it basically put all of our files into where your Python is installed and put it in a location where Python can find it when you say, okay, I want to import this. Okay, so this is really nice. Now you can have a very organized workflow. But say now you need to change something. So instead of it being a distance function, you want it to say like length function or something like that. You want to change the name of this function. Okay, so we got to change it into our test file too. Okay, not that one. We'll do a different one. So instead of get length, we'll say get distance. So we changed that in our test file. We were using get length, so now we need to change it to get distance. Okay, so the issue here though is that when we run our test again, we're saying, well, get distance doesn't exist. So we had built everything and installed it and then made a change to the original source. So in order for this test function to work again, we're going to need to rebuild our package and then reinstall it. And so it would be a tedious process if you're like in the development cycle to keep going back and making these changes. So I'll just show you that it will work again once we do all these things. So I'm saying I'm doing the build again. It's getting everything from Hatchling. All right, so we got our new distribution files. And now when we say install this time, we don't just put the file name, but we have to say, it's gonna say, oh, you already have this, this version, you're fine. And then we're gonna say, we have to actually manually reinstall this. So now we run our test file again. Okay, everything's working again. We changed the name of our function and everything's working. So this is obviously very inconvenient, but there's a nice way around it. And so that's to use an editable installation. And so to use the editable installation, you don't even have to actually build your project. You just have to say, this is going to be the source of where all my Python files are. And just constantly pull from this source. So I wonder I actually haven't tested how this works if you already have it installed. So yeah, I had it the wrong way around. So it's -E, and then so the period is saying install the project that's in this current directory. So everything that's in the workshop folder, that's the project. Yeah, so I guess we can test and see if it's actually an editable installation now. So before if I wanted to make a change, I had to go back and rebuild it, reinstall it. But now let's see if it works by itself. So we're gonna change it back to get length, and then our test, we're gonna need to change it back to get length as well. So now if we run it. Okay, so yeah, now we have an editable installation. You see, we didn't have to rebuild it and all that. It just works now. So this is what you would want to do if you were currently writing the tests, currently writing the examples, things like that. Yeah, so if you want to see an example of how this has been working, for the Solid Viz project that I've been working on, I've been using this sort of setup where I have the packages set up this way. Okay, so now is the time to, yeah.
So one more question on like rebuilding packages.
Uh-huh.
Would you expect there to be any performance improvement if you don't have like precompiled C code? If you just have normal Python code in a package and you rebuild it, would it be any faster?
So I don't think so, because for the normal Python files, it doesn't really, the wheel is just kind of like compressing them and then uncompressing them. So I think in that case, it's not going to be. For the editable installation, one thing I'm not sure about is if you do have things that need to be compiled from like C, if the editable installation will actually work for that. But then one other interesting thing related to that is if you ever noticed like a PyCache file in any of your folders, this is actually your modules, but like compiled. And so even when you are doing this editable installation, it's like compiling them. So maybe it's always going to be the same speed because of that fact. Yeah. Yeah, good question. Okay, so now I'm going to talk about what are the different vectors that you can share this your new wheel file with. And so pip, like I was saying, is what we've been using, and pip pulls from a repository. So GitHub's like a repository you can pull code from, but pip pulls from a repository called PyPy, so Python Package Index. But there's also other repositories. So I think Conda has their own, or maybe, and SourceForge is one, but I think maybe Conda pulls from SourceForge. But those are all different places where you can put your package so that people can download it. So I'm gonna try to show you guys how to do it through PyPy, through like a test PyPy site. And an interesting thing though is that you can also put it on your GitHub page. So if you have a GitHub for a project, there's actually a space for these types of files. So if you go to any one of your projects, you'll see a space on the side that says releases. And I'm pretty sure this is what you want. Yeah, so you would say like version 0.0.1, and then you could attach your wheel file to this, and then people could download that from your GitHub. And so, yeah, as far as like how much different that it would be from just cloning the repository, I don't know. It may be more important once you have like compiled packages, but this is one way you could distribute your wheel file. And another thing about your wheel file is it'll handle all your dependencies and stuff automatically. So that's something interesting. But clearly the Python package index is like the best vector because that's where people usually pull from. And if your package is a dependency for another package, pip will look at PyPy for that. PyPy. Okay. So yeah, let's try to do this. So to do this, it's really pretty straightforward. Again, we're just going to use another package called Twine. And so before we can do this, we got to just make sure all those packages are updated. So there's a package called package, interestingly enough, and that's one we're going to update to. and you do this capital U flag to update them. So something interesting, I think, is you'll see here, it says none and then any. And so that might be an indication that this is like a purely Python package, because before for NumPy, you saw it said Windows, AMD. So that was like, to me, that's saying that that has specifically compiled components that are just for that, that operating system and architecture. Bring a package. Yeah, and so before you could do any of these steps that I'm gonna do, you would need to create an account on PyPy. Yes.
You laughed at it. No, you laughed at me.
What?
Okay, so
Yeah, sweet.
yeah, so you need to create one of these accounts and you'll have different projects, organizations, and to do this, you will need to generate a key. And so to do that, you come all the way down here, you need to create a token. So I just created mine a little bit ago, but once you create, yeah, you'll need to have this token readily available for this. Once we get all of the packages updated. Okay. So I think the only way you can, like, you might think you'd be able to like automatically upload it. Or like manually upload it. Versus Twine, which is automatically uploading it. But I don't think there's actually a way to do it manually. So normally, if you wanted to upload this to so we're uploading the test Python package index, but if you wanted to upload it to the normal one, you would not put this test PyPy, I guess, input here. And then the final argument of this is, so we're saying Twine upload, and what we're uploading is repository. Uploading it to the test PyPy repository. And then our final one's just going to be where is our distribution located. So everything that's in the distribution folder. Okay, so now this is where it's asking for my API token. You don't see it.
She's the same person studying the same
I had a hard time pasting the code for.
Have to sit here and manually type it in.
No, I'm not doing that. I got it earlier. I don't know what I did. I forgot what I did. but anyways, once you do that, you'll be able to upload it. So I already did upload it successfully. I promise that's the last step before it gets uploaded. But you can actually install it like from the test repository. It still works in the same way. So if you guys can install my wonderful package if you want to. It's the same thing. Well, it might be like one different thing. But you can install the package. And so the way you would do it with this test repository, I guess any like other special repository that you use, like if you use something different than any of these, maybe like SourceForge, you would do kind of like this command down here saying pip install, and then you have to say where it's at because it's not in its typical location. So we're gonna use this URL. So this is where it's at, not the center location, and then the package name, geometry. Okay, so I guess because it's the same name, it's thinks I already have it, but yeah. So that it got that from the internet, so that's cool. So I know we already had step 5. I forgot to relabel this step, but it's just for extra reading. If you want to get even more organized about your project, I think a really good resource is this Pi OpenSci. They talk about just like best practices and stuff. And then we use what's called the flat layout, which has some advantages. So if this is a flat layout, you can see we have the name of our package just in the same directory as everything else. But there's also a thing called a source layout, which is it's more safe to use the source layout, but it takes a little more time to do things. And this is where like a lot of packages like NumPy and stuff are written in this flat layout, but a lot of them are running into issues where they want to convert to this source layout, but it's very hard and time consuming to convert. The only package that I've seen that has this source layout is scikit-learn. Checking all the other packages I use regularly, most of them use the flat layout. But in any of those projects, if you go look at their GitHubs, they'll have a lot of folders like this, and maybe we can go look at one just for fun. But yeah, NumPy is it's just sitting in here as NumPy. They have different tools. And then I think maybe their tests are actually inside of this folder. Yeah, so their tests are inside of here, and then no examples folder. But they have a lot of examples on their website, so maybe that's. But if we look at scikit-learn, you see the difference.
So
I could have swore they had a source layout. Oh, you know what? No, I don't know. Well, never mind then. But anyways, yeah, source layout versus flat layout. A lot of people still use the flat layout, but there's a lot of like push to use the source layout. Okay, so that's it for our workshop. Thank you guys all. If you guys have any other questions, I'm happy to answer.